All right, let's talk about something you've probably never actually held, but it's powering the very device you're watching this on right now. We're talking about a set of materials at the heart of a silent but incredibly high-stakes global struggle for technological dominance.
So here's a question for you. What on earth does a wind turbine have in common with a fighter jet? I know, it sounds a little strange, right? One is all about our clean energy future, the other is, well, the cutting edge of military power. But deep inside, they share a critical and, as it turns out, a surprisingly vulnerable secret ingredient.
And the answer is a group of minerals called rare earth elements. And you know what? They're not just connecting gadgets, they are fundamentally reshaping global power, turning what used to be a boring old supply chain into a full-blown geopolitical battlefield.
So, before we get into the global chess match, we really need to understand what these things are. Why have these pretty obscure elements suddenly become the hidden ingredients in, well, pretty much everything?
Now, don't think of these like your typical metals, not like iron or copper. This is a special set of 17 elements that have some pretty extraordinary magnetic and conductive properties. They let us create these incredibly powerful, yet super lightweight magnets and really sophisticated electronics. That makes them absolutely essential for everything from your phone's screen to an EV's motor to the guidance systems in the most advanced missiles.
And because they're so important, the way countries think about them is going through a massive change. Honestly, we're watching a fundamental paradigm shift happen in real time.
And this quote just nails it. For years, these minerals were just another commodity, something you'd buy and sell on the open market. But not anymore. Now, governments see them as strategic infrastructure, just as vital and just as much in need of protection as a country's power grid or its highways.
This really lays out the two mindsets perfectly. The old view was simple. It was all about price and availability. Can we get it cheap? Great. But the new view is all about security and control. It's not about the price tag anymore. It's about spotting geopolitical risks and deliberately building supply chains that you know you can rely on to protect your most vital interests.
So what caused this huge change in thinking? Well, it wasn't some gradual evolution. It was a massive wake-up call, and it was triggered by one single glaring fact about the global supply chain.
And that brings us to the core of the issue, a problem so extreme you can just call it the 90% problem. This one number sent absolute shockwaves through governments all over the world.
90%. Just let that sink in for a moment. In a totally globalized economy, it is incredibly rare for one country to have that kind of stranglehold on any vital resource. This single number represents a massive, massive concentration of power.
And here's what that 90% is all about. It's not about who digs the minerals out of the ground. It's about who processes them. That incredibly complex, difficult, and frankly often dirty work of turning raw ore into the high-purity materials we need. China controls roughly 90% of that global processing capacity. This is the critical bottleneck that everyone is now in a race to solve.
So, faced with that reality, a lot of countries realized the old way of just relying on the market was totally broken. They had to throw out the old rules and write a completely new playbook to secure their own supplies. And this new playbook, it starts with a checklist. Governments are now asking these key questions to figure out what's truly strategic. Is the supply all in one place? Is it really hard to process? Is it absolutely essential for our defense and our tech sector? And how easy would it be for someone to just cut it off? If a mineral checks those boxes, boom, it gets labeled critical and this new strategy kicks into high gear.
But just to make things a little more complicated, not all rare earths are the same. That term actually covers 17 different elements, and they're usually split into two main groups, light and heavy. And as you'll see, that difference creates a whole new set of strategic headaches.
This table breaks it down nicely. While the light rare earths are a big supply challenge, the heavy ones are a complete processing nightmare. They're way more difficult and expensive to separate. And here's the kicker. It's those heavies, like dysprosium, which you need for the super high-performance magnets in jet engines and wind turbines, that are the most critical for defense. So they become the absolute top priority, getting special attention, funding, and policies to build new processing plants from the ground up.
So what does this new approach actually look like? Well, it's basically a four-step process. First, you assess the risk. Second, you pass new laws to deal with it. Then comes the really hard part, architecting and investing. And we're not just talking about finding a new mine. This is about building an entire ecosystem from scratch, funding new tech, guaranteeing loans for refineries, and forming new alliances to create secure supply chains. Governments are now officially in the business of being supply chain architects.
So what this all means is that we are heading into a brand new era. The quiet, behind-the-scenes world of mining and minerals, it's now front and center in a global strategic competition.
At the end of the day, this isn't just about digging rocks out of the ground. Securing a supply of these elements is really about securing the ability to build the future. Everything from the green energy revolution to next-generation national defense. It's a race for technological sovereignty.
And that leaves us with one critical, lingering question. As all these nations scramble to break their dependencies and build their own secure supply chains, is this new race going to be defined by collaboration or by conflict? The answer is going to shape our technological and geopolitical world for decades to come.